And to do this, I'm going to actually do a contradiction proof. So assume to the contrary that the product is not greater than or equal to 0. If it's not greater than or equal to 0, then that means it's negative. So assume to the contrary that a times b is less than 0, and that I'm going to arrive at a contradiction. So if the product is negative, basically have two cases. Either a is positive and b is negative, or a is negative and b is positive. If I do one of them, the other one pretty much follows. It's going to be the same sort of scenario, but I'll go ahead and do it. So let's do the case, let's say case I. Let's do, so we have a times b is less than 0, and a is positive, b is negative. And we're going to form a contradiction. So we know the absolute value of a is equal to a, which is positive. Absolute value of b, since b is negative, the absolute value of b is going to be equal to negative b, which is positive, because b is negative. And let's see, so when I do absolute value of a plus absolute value of b, that's going to equal a plus negative b, which we know that sum has to be positive since a is positive and negative b is positive. But when I consider the absolute value of a plus b, right, that's equal to either a plus b if a plus b is positive, or it's equal to negative times a plus b if a plus b is negative. So neither one of these I should have done a different color. All right, hold on. There we go. So neither one of these is equivalent to a plus negative b. Okay, and specifically even the a plus b is not equal to a plus negative b. So therefore, we have a contradiction. Since we were assuming absolute value of a plus b is equal to the absolute value of a plus absolute value of b. All right, so, and that means since we assumed that and proved otherwise, that gave us a contradiction, and that was using when a is positive, b is negative. The other case is done pretty much the same. So again, we're assuming the product is negative. This time we're going to assume a is negative, b is positive. It's pretty much done the same as this one. You're just switching the roles of a and b in the previous case. So hence, it is not the case that the absolute value of A plus B equals absolute value of A plus absolute value of B if the product is negative. Or when A times B is less than 0. So therefore, A times B is going to be greater than or equal to 0, since we proved it otherwise for the less than 0 case. All right, so that completes this problem, and this was taken out of Bartle's textbook, Intro to Real Analysis. I've been pretty much picking problems from, it's going to be mainly from Jay Cummings' textbook and the Bartle's textbook. I will pick a problem or two from Rudin's textbook, but Rudin's a little bit more difficult than what I was hoping for this course. All right, so I hope this helps.